So students, after continuity we'll discuss about differentiability of function. In the class 11th you have studied about derivatives of function. So let's see the definition of derivable function. Let f of x be a real valid function defined on an open interval ab and any point c is there in the open interval ab. Real valid function. A function is said to be real valid function if its range is either set of real numbers or any its subset of real number. Okay? Any subset of real number or set of real number is the range of any function, then it is said to be real valid function. So if f of x is a real valid function defined on the open interval ab and c is any point in this interval, then f of x is said to be differentiable. This function f of x is said to be differentiable at x equal to c if limit of f of x minus f of c upon x minus c when x tends to c exists and it is finitely. Okay? Any function is said to be differentiable at point x equal to c where c is in the open interval ab if this limit exists. If this limit exists, function is said to be differentiable at x equal to c. If function is differentiable at x equal to c, it means this limit exists. If function is differentiable at x equal to c, then this limit will exist. And if this limit exists, it means function is differentiable at x equal to c. This limit exists finitely means its left and right hand limit exist. That is limit of f of x minus f of c upon x minus c and x tends to c negative is equal to limit of f of x minus f of c upon x minus c when x tends to c positive. This is left hand limit, it is right hand limit. Okay? So this both limits exist. If we replace x by c minus h, then what we get? F of c minus h minus f of c upon x is c minus h. When x is c minus h, okay, x equal to c minus h. When x tends to c, then h tends to 0. So now limit is h tends to 0. And here it is right hand limit, so we replace x by c plus h. So you get f of c plus h minus f of c upon c plus h minus c. Then h tends to 0. Okay? So here c cancel, here c cancel. Then you get limit of f of c minus h minus f of c upon minus h is equal to limit of f of c plus h minus f of c upon h when h tends to 0. So this is called left hand derivative function, and just didn't write left hand derivative like this. For derivative of any function f of x, we use f dash of x. And last year we have seen derivative function, we write f dash of x. So it is left hand derivative. It is right hand derivative, so we write r f dash of c. We are finding derivative at x equal to c, so we write f dash of c. So this function is differentiable if this limit exists, means left hand derivative and right hand derivatives are equal. This is called left hand derivative and we denote by this. It is right hand derivative, we denote by this. So when a function is differentiable means its left hand and right hand derivatives are equal. Both exist and they are equal. ठीक है? Let's take an example. Show that the function f of x defined by this is not differentiable at x equal to 2. We have to show this function is not differentiable at x equal to 2. It means when we find its left and right hand derivatives, they will not be equal. ठीक है? चलिए, so first left hand derivative function at 2. And left hand derivative of any function at c is what? Limit of f of x minus f of c upon x minus c when x tends to c. So by this, left hand derivative at x equal to 2 will be limit of f of x minus f of c. So c is 2 here upon x minus 2 when x tends to 2. ठीक है? Now in this case, when x is less than 2, now we are finding left hand derivative. So x should be less than 2. When x is less than 2, f of x is x minus 1. So f of x will be replaced by x minus 1 minus f of 2. When x equal to 2, f of x is 2x minus 3. So it will be 2 into 2 minus 3. F of 2 will be 2 into 2 minus x. When x is 2, f of x defined as 2x minus 3 upon x minus 2. So it is equal to limit of function x. Now it is 4 minus 3, 1 minus 1 minus 1 minus 2 upon x minus 2, which is equal to 1. Now both cancelled. So limit of constant will be same one only. Now right hand derivative at 2 will be limit of f of x minus f of 2 upon x minus 2. This is left hand limit, right hand, na? So we can write minus plus. So now in this case, limit of f of x. Now in this case, f of x, when x is more than 2, f of x is 2x minus 3 minus f of 2, same 2 into 2 minus 3 upon x minus 2. So it is equal to limit of 2x, 4 minus 3, 1. So minus 3 minus 1 minus 4 upon x minus 2. So limit of 2x minus 4 upon x minus 2 when x tends to 2. If we get 2 common from here, then we get x minus 2 into 2 upon x minus 2. So x minus 2 cancel and we get 2 only. Its limit is 2. So left hand derivative is 1, right hand derivative is 2. So since left hand derivative and right hand derivative of function at 2 are not equal, therefore f of x is not differentiable at x equal to 2. Okay, this function is not differentiable at x equal to 2. So if you want to find the function is differentiable at one point or not, find its left hand derivative and right hand derivative. If both are equal, function will be differentiable, otherwise will not be differentiable. ठीक है?